Can you read the problem to me? Because I don't have a.
5x to 8 minus 3.
I'm sorry. Can you start over, please?
5x to 8 minus 36 45 x squared.
So when I look at this, what am I going to do first?
I take x squared out of.
I don't want a CF. I want the GCF. Listen, all right, fine. In your defense, pulling out x squared is pretty rad, but that's not going to get this done because it's not the greatest common factor.
Wouldn't it be 5x
Yes,
squared?
it would be 5x squared. And I'm telling you, the way I build these, there might be occasions in which just finding some random common factor is good, but I'm not going to write those for you. I'm going to always expect you to get the greatest. I'm not going to trick you. Okay? So when I write a problem and I want you to find it and I hide it from you, I'm going to hide it under a GCF, not just some random thing that you have to guess. So what's left of this problem when I pull out the 5 and the x squared?
X to 6.
Yeah.
Minus. $7.29. That'd be a difference 2 plus 9 x cubed minus 9.
No. So, hey, fancy fun fact. I think I learned this one yesterday. And as a grown-up, I feel like I should have already known this. Do you guys know what that number is? It is a cube. Do you know what else it is? It's a square. And that's one that's not familiar. I don't know what was going on with my brain, but I keep seeing 729 as a cube, which is great because it is. But it is also 27 squared, just for the record. And so when you see that number in the future, if you're still listening, great to have in your notes that, hey, this one can kind of go either way. So in this case, Tristan, we're going to see it as squares, okay, not cubes. You with me? Okay. So when I factor it down as a difference of squares, it's going to factor down as x to the third plus 27
Minus 27.
times x to the third minus 27. All right. So again, that could have been one where we would get fooled and go down the cubes road. And then remember, the cubes road is not the road we want when we're given a choice because we're going to miss some of the meat on the bone. Now what do we see? I'm going to have a lot of awkward pauses in my video if you don't answer my questions using words, because I'm trying to do this so that anyone, it's okay, but they're cubes, right?
Yeah, it'd be a equals x, b minus equals 3, and then
Okay.
it's the same.
Good. So you got A's. Okay, that's what
Sorry, that's my bad. I was
that's okay.
writing it down.
You're fine. I know you were, and I appreciate that. And then B equals.
So you'd have 4 sets of.
Right. So we're gonna have our
long, short.
So we're gonna have our GCF, and then we're gonna have short, long, and then another short, long.
First B, which is equal to minus. Would it be x? Would it be bx if you were to multiply? No,
AB is just 3x.
I keep on beating, and that's what I mean. Minus 3x plus 9.
Okay, and now let's do the other one.
Equals to minus 3.
Yep.
It's x squared plus 3x plus 9 plus 1.
And that's it. And we know we're done because the only things that even have potential are quadratics, but we know that the long set is not going to be touchable anyway. So we're done. Still with me?
Yeah. X is
So I finally printed myself a copy, so I don't need you to read me the problem. So yeah, I should have done that a long time. So I'm looking at y(x to the 6th) plus 216 y to the 7th. So the way I look at that is there is a GCF, but it's not very extensive. There's just a y, right? So that leaves us with x to the 6th plus 216 y to the 6th. You looking good so far? Okay. So what is that? It is, and that's all it is. It has a couple things that make us want to think it's a difference of squares. The x to the 6th and the y to the 6th are pretty enticing, but the plus sign immediately rules it out, and so does the 216. So all we can say is it's a sum of cubes. So what's a? Yeah, I really need you to, it's x to the 2nd. I need you to remember when we are cube rooting down to find a and b, we divide exponents by 3. And then what is b? Six y squared. The 6 comes from the cube root of 216, and the y squared comes from, again, dividing the exponent by 3. Are you with me? What I guess what I want to know is if you were faced with this problem again, would you understand how to find a and b?
Yeah.
Okay, good. So now it's just time to do our short set, long set, and see where that takes us, what the future holds. And so I copy down my GCF, and then I build a short set and I build a long set. And go ahead. Yep. 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 Minus. Perfect. Yes. Plus. Oh, okay. Right. You got it. That's it. And right, that first set of parentheses has very little going for it. Again, the y squared and the x squared are delicious, but the 6, the plus sign, it's like, I want to be squares, but I can't. So, Kinsley, does that make sense?
Yes.
Did I forget something?
the 36y should be
The 36 should be 36y to the 4th, Kinsley. Yeah. Thanks, Tristan. Thanks, buddy. So number 7, the first thing I have to do is pull out a GCF. And the GCF looks to me to be a 3 for sure. And then I can also pull out a singular x. We agree on that? Which is going to leave us with x to the 9th minus, what is that, 512. That's it. We agree? Okay, so what is that? Yeah, 100%. There's very little square action going on here. So so my a value is, and my b value is Nope, 6 is 216, 7 is 343, so it's 8. Yep. So the cube root of 512 is 8. But I do see that you were about to go to your resources, and that's pretty rad. So good job. So now we're going to build short set, long set. What's going to go in short set? Long set? You think what? Okay, I'll be done in just a moment. Everything feel good so far?
Yeah.
Okay, so you and I need to agree that the long set is now dead. It's going to just be a dead weight that we carry around for the rest of the problem. But what about short set?
Well, it can't be definitely squares because it's 3.
Right.
Right.
Right. And 8's not a square either. So, I mean, it's the only similarity it has to a difference of squares is that it's a difference.
So
It has the difference of cubes, right? So this isn't one where we have any options. This is the math gods are barking an order at us to go yet again. So we take it to the next level down. What's A? And what's B? So now when we rebuild this, we copy down our GCF. And now we're going to build a new little baby short set, long set. And then we're also going to transfer down the long set from above. I can just tell from the work you've been doing that that just makes sense to you. Like the difference of cubes, right? So that's some problems only, like problem 6, Tristan and I just did that. It only has the one level. You do it once and you're done. And then some problems like number 10, you have to go like 3 levels or 4 levels deep. So it just varies from one to the next. But your job is to see them and say, I know you, like I know what you are. So what are we going to put in our sets here? Yeah. That's a completed project because again, those long sets are dead. And all we're ever going to look for to get more meat off the bone is look at the short set. And if short set has meat on the bone, that's where you go. If not, you stop. You want to go over number 9? Yeah, sure. I know why I would get 9 wrong if I were in my own class. So first off, again, let's just pull out the GCF. So if we pull the GCF out, it is 2x. And then what's left over is 1 plus 64x to the 6th. So this is one where I wanted to walk you guys down a path, the temptation of, like, one of the things I try to do leading up to this quiz is like test your fortitude. To say, like, can you look at something and not fall for a trap? I wanted you to look at this and think squares, but why wouldn't it work? Because you should always look for squares first. Squares are where you always want to get the most bang for your buck. So squares should be like top pick. Always look for squares because 1's a square, 64 is a square, x to the 6th is a square, but it's a plus. So the moment I see that, then no matter how tempting it is, I say squares, you're off my, you got it. I like it when I watch you guys make notes to yourself. I always think it's what good, smart people do. Remember, and I think I don't say this enough. Squares can only be factored if it's a minus in the middle. I feel like you know that, but if you don't, write it down. Squares only work with minus. Got it? So like this problem that's on the TV right now, you look at it and boy, is it tempting to look at that white thing and say, hey, there's squares. But the plus says no, don't do it. Stop. So if I can go anywhere, it's going to be cubes because cubes don't care. Cubes can go plus or minus, right? So yeah, I'm glad you got that. Squares do not work with plus because what makes squares work is the plus and the minus canceling each other out. And you can't do that. A plus and a minus will never multiply to make a plus, which is why that doesn't work. If that makes any sense. So as we do have to go down QB road. So what is A? And what's B? 4. No, that's how you do it. Now, there's one more temptation. So I kind of laid it on thick in this problem. The first temptation was to get you to overcome that first wannabe difference of squares. You pass the test, but then there's going to be another one here. So let's start by copying down our GCF. So we're going to pop down the 2x and then we're going to build a short set, long set. What's going to go in short set? No, that should, yeah. So 1, right, then plus. Nice job. So the last layer of temptation, I did it to you again. It's obvious what my intention was here was I wanted you to look at that and test yourself and say, you're not squares. I'm moving on. And then I wanted it to happen again right here. You see that there's another wannabe where you look at it and go, hey, those are squares. But again, the plus says pump the brakes. So this is actually a completed project at this point. Does that make sense? You're welcome. Kinsley, you still have a question? Which one? Sure. Okay. You have to, when you get structural problems that are built like this structurally, you have absolutely got to put quadratics, all that stuff out of your mind, and you have got to say, are you squares and are you cubes? So the first thing we can rule out is the squares because 27 is not a square. There's a 1 that's a square, and u to the 6th is a square, and man, that's a minus sign. So I'm getting pretty excited, but then 27 breaks it. So now I have to change gears and say, are you cubes? Are they cubes? Yes. So I'm not done. I am not going to stop. If they're cubes, that would be like leaving a whole bunch of meat on the bone. What is A? And what is B? No. What is the cube root of 27? The cube root of 27 is 3. Thank you. Good job, Serenity. So the 3 comes from cube rooting the 27. The u squared comes from dividing the exponent by 3. Solid. Now it's time for us to build our short set, long set. So I'm going to bring my 3u down and I'm going to build a shorty and a longy. What goes in shorty? Right. Just work. Corbin. Mason, can you let Corbin know I was talking to him? Corbin, just work. I don't want you guys off topic and all that. Just work. Long set? Yeah. Then what? Hold on a second. You just, yeah, that's a times b, so 3u squared plus. Now, again, I'm not writing these randomly. I'm not sitting, so honestly, some of them I let the computer write, but I try at every stop along the way to keep planting temptations for you guys to make you better at this. So what I wanted you to see in this particular problem was I really wanted you to look at this and get tempted because it's got a lot going for it, doesn't it? It checks a lot of boxes. 1 is a square, that's a minus sign, and u squared is a square. The 3 is not. So I have to pump the brakes on it being squares. So then I think about cubes, and it's not even close to being cubes. The 3 is not a cube, and the u squared is not. You can't divide by 3. What's the moral then of that story? It's done. Right. Did I just resume my recording? I did. So you pulled out the, so this is problem number 10?
Yes.
And you pulled out 5x to the third?
Yes.
And that resulted in,
X to 12 minus 1. B square root.
yeah, they're squares, right? They're cubes, but they're definitely squares, and we always go squares. So we're gonna copy down the 5x to the third. And that's gonna leave us with x to the 6th plus 1 times x to the 6th minus 1. This is where the fun begins, because this is a really unique situation, because now you've got a little bit of each flavor at the next step.
Well, your x to the 6 minus 1 is another square.
Say again?
Your x to the 6 minus 1 is another square. Not a cube.
So this is unique because we have a little of everything here, right? What is x to the 6th plus 1?
It's a cube.
It has to be, right? And I will say that the x to the 6th and the 1 are squares, but the plus rules it out, right? So we have to attack that side as cubes. So what is A?
A is x squared
What's B?
and B is 1.
Nice. Now we also, while we're here, let me get over here to this side. I'll put a little purple underline underneath. What is that, Tristan?
He's a square.
He is. And just like the other guy, x to the 6th and 1 are squares, but because he's got a minus, I can factor him the better way, right? So now we're going to have some pieces that show up. So we're going to keep our 5x to the third.
We're moving down.
Right. And then we're also, while we're here, why don't we go ahead and short set, long set, attack these cubes.
B x squared plus 1.
Right.
C x to the 4 minus x squared plus 1.
Right. And then let's talk about that purple thing up there. How are you going to factor that guy down? Are you deep in thought?
Yeah.
I know you know how to factor a difference in squares, Tristan. We don't need A's and B's.
It would be 3 x cubed. It'd be x cubed
Keep
when you
going.
put it down.
Yeah, right. And remember, this isn't an AB thing. So remember with squares that we just go like this. I'll just show you the short way that I do it. When I know I have to factor squares, here's what I do. I'm going to color code this for you, okay? What's the square root of that? That's
X
right.
cubed
So we put that there and there. And then, of course, what's the square root of that?
plus 1 minus 1.
So I put a 1 and a 1. Remember, I don't need a formula for squares. I just do the old plus minus trick. Oops, except I did the plus plus trick. There you go.
Then
And it would be almost nice if it were to end, but guess what? Look
You
through
can-
all your factors and examine everybody. What do you see?
you can cube the squares.
What a second. You just said you can cube the squares, son. Are you trying to give me a head explosion, some kind of aneurysm? What does that mean?
I mean, I was meaning the x cubed plus 1, x cubed minus 1 cube.
You can factor.
Factor. That's what it's
Right. So you can factor the cubes. Right. So what I have now, basically, I'm going to put check marks under everybody that's dead. Dead, sum of squares, dead, long set, dead. However, as I head down the road here, I realize, oh, snap, I got myself a couple of little baby problems now. So I got to do AB here. A is X, B is 1. And then I got to do AB down here. A is X, B is 1. And now you're going to spawn another 4 sets of parentheses now, in addition to what you already have.
So do you just drop the first long set down?
You drop all 3 of those things down. Yeah, basically everyone that I checked as dead, it should just be a copy down. Now they just hang around like a bad cold. However long the problem lasts, they just get copied every step.
Okay.
Right. And now you're going to short set, long set each of those green and yellow pairs. You pulled out negative 4x to the third, and we're left with x to the 6th. You forgot to change your sign. So no, that needs to be a minus 64, which is going to completely mean you have to erase all of this, because now this is a difference of squares. And that's the path you need to go down. So when you pull a negative, switch your signs, right? Okay. How you doing, Erica? You getting all this stuff? Okay.
Trying to
Are we on the assignment 8? Let me make sure I think I'm still recording. Hang on a second.